Okay, in this problem, we have an object on a spring oscillating with a period of 0.8 seconds and an amplitude of 10 centimeters. Let's just draw that. I've got an object, draw an object on a spring. Okay, this is at x equals 0. It has an amplitude of 10. Okay, so let's assume that an amplitude of 10 usually means that when it's stretched, as far as it's going to stretch, so let's say it's like going to be out here, right? This is 10. That's the distance from the equilibrium out to the point of it being fully stretched is 10. So my A, so let's say my given is A is equal to 10. And the other thing I'm given is that the period is equal to 0.8 seconds. Okay. And it's telling me, though, that at time t equals 0, so let's just say I pulled this block away toward and had it at 10 and started it going but forgot to turn on my clock. So at some later time, I turn on my stopwatch, and so time t equals 0 is not the same as when I first stretched it to 10. It's some other time. And so I'm going to learn what that other time is, and that's going to have an impact on what my phase constant is. So since my time is not starting right at 10, then I have I'm going to have a phase constant because it's at some other position. Okay, so it's telling me then at t equals 0 seconds, it's 5 centimeters to the left of equilibrium and moving to the left. Okay, so if you think about this, when I originally set this up, right, this was my position here, and I imagine I pull this block back and I'm holding it at this position. And when I let it go, it's going to be moving to the left. Okay, but in this case, right, it's actually moved all the way, like it's still moving to the left, but my block, say, is here. Right here is when at 5, and I didn't draw these very well, but 5 is the distance, and it's a -5 actually. So the distance from here to here is 5, but it's to the left of 0, so therefore it's negative, and it's still moving this way. Right, and so that tells me it's going to go all the way to 10 before it's going to be fully compressed at 10 and then start going back to the right after that. But at this time right here, at when x equals -5 and it's moving to the left, that's when I hit my stopwatch, and that's my time t equals 0. Okay, well, let's think about a graph of this, right? If I were to do, imagine I started like I wanted to, right when I first let it go, I would have a graph that looks like this, right? It's max, it looks like that, right? It's at my amplitude here at A, right? But I didn't start it there. I started at some other time. And so the way I started was, let's see, I know that I'm not at 0, I'm to the left of 0. So if I think about how does this top graph trace out? Well, this is my starting spot here, right? And then when I get to 0, it's heading to the left this way. It's heading to the left this way. And I get here, and this connects with that point, right? And then if I think about this point, or let's make this red, the red point right here, that's the same as right here. You know, it's at a half. It tells me the position is a half, or I'm sorry, 5, but it started out at 10. So if A equals 10 here, and A equals -10 down here, and 5, it's halfway right there at 5. So it's starting there. So what I need to do is, okay, it's starting there. So if I think about this, it's like that, right? So this spot is the same as that spot. Okay, well, if I think about what is the phase constant, right, from here to here is pi over 2, and then I have a little bit more. And how do I figure that out? Well, I know that cosine, I've got cosine. Cosine is equal to half of the amplitude when the angle is 60 degrees. So that, I'm talking about like this is my half. And so this theta right here is 60 degrees. So what I need to do is I'm like 60 degrees. So from here to here, this is, let's see if I can, I want that. So from here to here is 30 degrees since this part is 60. And that means from here to here, where this one lines up, right, that's another 30. So I've got the full 90 to get to 0, to get to where it hits the 0 on the axis, plus 30. So I'm going to say then that that angle theta is equal to 120 degrees. So when I write out my equation, I have x of t is equal to a cosine of omega t plus phi. And a is 10. Then I have cosine of omega. We'll get to omega in a minute. Omega t. But now my phi, I'm going to say this is 120 degrees. Right? So what I've done is going from here to here, right? This spot right here is the same as this spot right here on the top graph. But I can't write this in terms of degrees. I have to write it in terms of radians. So I'm going to say, okay, x of t is equal to 10 cosine omega t. And then how do I figure out what 120 degrees is in radians? Well, the trick that I learned was that I know that that 180 degrees is equal to pi. And so, if I want to know what 1 degree is, I just divide both sides by 180, so I get pi over 180. So if I want to know what 120 degrees is, I just say 120. I have to multiply it by 1, and if I multiply 120 by 1, then I have to multiply the right side by 120. So 120 times pi over 180. That's how I learned to do it. And so 120 degrees is then, I can take this and I can say 60 goes into 120 twice, 60 goes into 180 3 times, so 2/3 pi. And so I get then, this is equal to plus 2/3 pi. All right, now what about my omega? Well, let's do omega right here. Omega is equal to 2 pi over the period. And remember, the period is 2 pi over 0.8 seconds. And omega is equal to, so 2 pi, 8 seconds is 8 over 10. Or, I mean, 0.8 seconds is like 8 over 10. And so that's equal to 20 over 8 pi. And that simplifies to, both of them contain a 4, so that's going to be 5 halves pi. So that's my omega. So now, let's move up a little bit. X of t is equal to 10 cosine of 5 over 2 times pi times t plus 2/3 pi. Okay, so it asks me, let's see what the question wants to know. It asks me, what are the position and direction of motion at t equals 2 seconds? So I should have done find, so let's just write it up here. Find x and the direction at t equals 2 seconds. Okay, we can figure that out. So we can plug in. So we'll just plug in for t 2 seconds. So I have x of t is equal to 10 cosine, all right, 5 over 2 times pi. Now it was 2 seconds, so I'm going to plug in times 2 plus 2/3 pi. And so my 2's cancel here, right? And so I have x of t is equal to 10 cosine 5 pi plus 2/3 pi. Okay, so I could just plug this into my calculator, right, and figure out 5 plus 2/3, right? I could figure that out. It ends up being 17. The argument is 17 over 3 pi. But instead, and so I could plug that in my calculator and figure something out. But instead I decided, well, I want to think about just a cosine graph, right? If I have a cosine graph and I want to know what 5 pi plus 2/3 pi, what I get, I'm just going to draw it out. So there's 2 pi, and there's another 2 pi. Right, so I'm at 4 pi, and now I go down here and I'm at 5 pi. Okay, so I'm at 5 pi, which says I'm to the left, right? If I think about my spring, my block, right? If I'm stretched this way, if I have my block over here, that's in the positive direction, and if I have my block over here, that's in the negative direction on my graph. Right, so right here would like measure up with this spot right there, and up here would measure up like this spot over here. So I'm at 5 pi here, and I have to go to 2/3 pi. Well, 2/3 pi, right, is from here brings me up to like here. And this spot right here, 2/3 pi, if I plug that in, I would actually get 60. It would be like 60 degrees, which means I'm at the halfway point. So this means this spot right here is going to be x equals 5. Right, so over here, I know that probably isn't drawn right, but right here, this is going to be x equals 5. So, and I know that I'm moving to the right. So my x is going to equal 5 centimeters, and it's going this way. So if I'm here, if this is my equilibrium, my new spot is right here in between at x equals 5. And it's moving to the right.